Hello everybody, welcome back. Last video we talked about how to simplify square roots that do not have perfect square numbers if possible. And today we're going to talk about radicals or roots as well as what's called rational exponents and how they're related, how we can rewrite them from one form to the other. So first, when we talk about roots, as we talked about in the past, it's something with this type of symbol. So a square root or a cube root, something like that. It can be a different type of root than you might be used to seeing, fourth root, fifth root. These are things that we're going to be exposed to a little bit today. And then the concept of a rational exponent. So that's an exponent, that's a fraction. So something that might be a power of 1/2 or a power or exponent of 1/3, or maybe something like 9/2. Okay, you might not be used to seeing that. We're going to see the relationship between these two different things today, and how we can rewrite from one form to the other. So what might be the best place to start is to ask ourselves maybe a simple question. For example, what is 9 to the 1/2 power? If you go back to one of my earlier videos, I think that I showed 9 squared is very simple. It's 9 times itself. But 9 to the 1/2 power has to ask something different. It can't be 9 times itself, and if you type that in the calculator, you're going to get a 3 actually, and there's something interesting about that. Let's consider one of our original rules that we talked about in our first video, and that's the product rule. What I'm going to do here is I'm going to take 9 to the 1/2 power, I'm going to multiply it by itself to see what happens. Now, according to the product rule, right, we have two numbers being multiplied that have the same base, 9 and 9. The product rule says that when that happens, we can add these two exponents. 1/2 plus 1/2, and 1/2 plus 1/2 equals 1/2, right? And since we know that anything to the first power is itself, what we've just shown is that these two numbers multiplied to give 9. Now, what number multiplied by itself gives a 9? And I hope you know that the answer is a 3. 9 to the 1/2 power has to equal a 3 because only 3 times 3 equals 9 at the very end here. So 9 to the 1/2 power is 3. Is there another type of problem that you can think of that involves 9 and 3? You might be thinking 9 divided by 3. Yes, 9 divided by itself is 3. Actually, what I'm thinking about here is square roots. The square root of 9 is also 3. Why? Because 3 times itself equals 9. Just like when we said in previous examples that are perfect squares, right? 1, 4, 9, 16. These tell us what we can find multiplies by itself to give these perfect square numbers, right? 4 times 4 is 16, so the square root of 16 is 4. What this shows is that there's a relationship between rational exponents and square roots, or roots in general, or radicals in general. Okay? And that's that they can be represented as the same thing. For example, there are two different ways that you can write a square root. And we just showed them actually. We can write a square root like x to the 1/2 power. This is called rational exponent form. Or we can write this in radical form as well with this little half box symbol. Both of these things mean the same thing, right? We're looking for a number that multiplies by itself to give, in this case, x. In an earlier case, it was 9. So since they mean the same thing, we should be able to rewrite these problems from one form to the other. And that's what we're going to do today. We're going to learn how can we rewrite problems from one form to the other. And specifically here, I'm going to be focused on moving from radical form to rational exponent form to illustrate a principle. So I have 3 examples here. We're going to go through each of them, see how we can rewrite from one form to the other, and then a rule that we can use in such cases. So, okay, we start with radical form here. We have a root of 4. This is a fourth root. And a power of 3. The way that we're going to rewrite this And you can test this, by the way, by plugging in a number for p, maybe try something like 8, is to put these numbers, this 3 and this 4, in fraction exponent form. So rational exponent just means fraction exponent, right? This is a fraction exponent. We're also going to have a fraction exponent here. And they're going to go in specific places. The power is always going to go on top. The root is always going to go on bottom. This is the way that we would rewrite something from radical form to rational exponent form. Okay. Another example, the 6th root of x, and in this case, remember that you always have this type of invisible exponent of 1. Okay. How would we rewrite this? Same principle. That power is always going to go on the top of a fraction, in this case the root 6 always on the bottom. This is how we would rewrite something from radical form to rational exponent form, from something that has that little half box in the rational exponent form that goes away. Now you have a fraction exponent. And the rule here basically that I think is helpful to students is that roots are like tree roots. They always come out from the bottom of the tree. They always go on the bottom of a fraction. That's where roots go. Powers, being powerful, are always on top. They're always in the top of a fraction in your exponent. So one last example here to illustrate that. Once again, your root is 5. It's a 5th root. So 5, because it's a root, like a tree root, will go on the bottom of a exponent fraction. 10, because it's a power, and it doesn't matter if that power is outside or inside, you can put it in either location. It means the same thing. We can put that 10 as a power in the top of our fraction exponent. And notice we can simplify this a little bit here as well, which is why this is very useful sometimes to rewrite problems in a certain way. Right? From radical to rational exponent form, this allows us to see how we can simplify this, because 10 divided by 5 is just a 2. Okay. So rewriting problems, we're going to see in our next video where I actually do some simplification using this fact that we can rewrite from one form to the other. It's going to be helpful to us to know how to simplify different types of expressions, but I'm going to leave the video here. What the main thing is that you need to know rational exponents means fraction exponents. Radical form is when you have that little half box square root symbol, and that these mean the same thing as long as they have the same root and the same power. And that's making sure that happens is by following this principle. So I'll see you in the next video. We'll talk about how to simplify some actual expressions together, and I'll see you then.